In this video, we will learn that if you memorize 3 special trig values, you can find the rest of the trig values in any quadrant. Now, in the previous video, we learned that if you memorize 3 trig values, you can find the rest. But we stuck to the first quadrant. We only dealt with pi over 6, pi over 3, pi over 4, and pi over 2. We didn't go anywhere else on the circle. So, first of all, please make sure you watch the previous video before you watch this one. Alright? This video will not make much sense if you didn't watch the other video first. So, stop this video, go back and find this video, and watch that first. Now, assuming you've done that, and I also have to assume that you followed the directions and memorized the 3 critical values. Here they are. I want you to memorize that the sine of pi over 4 is 1 over radical 2, also known as radical 2 over 2, but I'm going to use the first version today. And I want you to memorize that the cosine, no, let me stick with sine for a second. I want you to memorize that the sine of pi over 6 is 1/2. Okay? And I want you to memorize that the cosine of pi over 6 is radical 3 over 2. I want you to memorize these 3 facts. And everything I do after this moment is going to be under the assumption that you've already memorized these 3 facts. I just reorganized, I moved this one over here. Now, so what I would do when you have an assignment or a quiz or test or something, I would write down these 3 facts at the top of your paper, sort of like I'm doing right now. And then these 3 facts will immediately lead to 3 other facts that I would also write down at the top of your paper. So, for example, the cosine of pi over 4 is the same as the sine. So go ahead and write that down. And now, we know that for pi over 3, these get reversed. So we will say the sine of pi over 3, and we'll have the cosine of pi over 3. But these will be reversed. So the radical 3 over 2 will now be for the sine, and the 1/2 will now be for the cosine. So you memorize these 3 pink ones, but then the blue ones, you come from them very quickly. So have these written down at the top of your paper. Now, number 1, if we want to find the secant of 5 pi over 3. First of all, the secant is the reciprocal of the cosine function. So let's just start off by finding the cosine of 5 pi over 3. Okay? Now, the cosine of 5 pi over 3 is going to be the same thing as the cosine of the reference angle pi over 3, except for the sign. Alright? It could end up staying positive, but it could be negative. So we have to just figure out what the sign is. Okay? But the cosine of pi over 3, we just wrote that down at the top of our paper, so that's going to be 1/2. So we know that this is going to be 1/2. It's just a matter of will it be positive or negative. The way you figure out whether it's positive or negative is you draw a quick unit circle. Okay? Now we're dealing in pi over 3's. So if I were you, I would just divide our unit circle up so that we have pi over 3's. Okay? Remember that a semicircle, alright, 180 degrees, that's pi. So that means each one of these up top is 1/3 of a pi. So these are pi over 3's that we're looking at. Okay? So as I go around, I'm thinking that this is 1 pi over 3, 2 pi over 3, this is 3 pi over 3, this is 4 pi over 3, and this is 5 pi over 3. right here. So if this is the initial side, this is the terminal side, so this is 5 pi over 3 right here. So we just need to know the sign of this location. Alright, let me throw my x and y axis back in here to be clear. Now remember that every point is in the form cosine, comma, sine on the unit circle. So the cosine is the x value and the sine is the y value. So all I need to know is this positive or negative? Well, we're dealing with the cosine, so we're talking about the x value. So is the x value positive or negative in this quadrant? Well, it's to the right, so that is positive x value. So that tells us that it'll be positive 1/2. But this is not the final answer, because remember, we were finding the cosine, but the secant is the reciprocal of the cosine. So the final answer is going to be that the secant, I guess I don't really need to recopy it, but maybe I will. The secant of 5 pi over 3 is going to be the reciprocal of this. So 1 over 2 becomes 2 over 1, or simply 2. So 2 is the final answer. Let's look at a couple more examples. If I want to find the cotangent of 8 pi over 3, well, this is the reciprocal of tangent. So let's start with finding the tangent of 8 pi over 3. Now the tangent of 8 pi over 3 is going to be the same thing as the tangent of the reference angle pi over 3, except for maybe it'll be positive, but maybe it'll be negative. Okay, now tangent is sine over cosine. So just looking up here at the top of my paper, sine over cosine, just look at the numerators here. That's going to be radical 3 over 1. So the tangent is going to be radical 3. But maybe it'll be positive, maybe it'll be negative. I need to figure out which one it is. Alright, the way I figure out whether it's positive or negative is I'm going to look at the unit circle. So just quickly draw yourself a unit circle, divide the top into 3 equal parts, so you'll have pi over 3's, and then start counting. Alright, I want 8 pi over 3. So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8 pi over 3. Alright, 8 pi over 3 is going to end up right here. Alright, so here's my x and y axis. We need to know the signs of this point, as in positive, negative. The x value is negative, alright, because it's over here to the left. The y value is positive because it is up. So we have a positive and negative. Now remember, this is cosine and sine. But tangent, remember that tangent is sine over cosine. So that means, in this case, the tangent is going to be a positive number divided by a negative number, alright? Because the y value is sine and the x value is cosine. But a positive divided by a negative is a negative. So that means the tangent is going to be negative in this quadrant. So it's going to be negative radical 3. But that's not the final answer. We are supposed to find the cotangent. And the cotangent is the reciprocal. Alright, so the cotangent of 8 pi over 3 is going to be the reciprocal of this. So just put a 1 over it. So it'll be negative 1 over radical 3. And that is the final answer. Alright, let's look at one more example. Number 3. Well, cosecant is the inverse not the inverse, the reciprocal of the sine function. So let's start off by finding the sine of 5 pi over 3. Now, the sine of 5 pi over 3 is going to be the same thing as the sine of the reference angle pi over 3, except maybe it's positive and maybe it's negative. We're going to have to figure that out. We can figure that out by drawing a quick unit circle. Alright, since we're dealing with pi over 3, let's divide this upper half, this pi, into thirds. Okay, so 5 pi over 3. This is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. So this is 5 pi over 3. Now, the question is sine positive or negative in this quadrant? Now, I say quadrant. Let's put the x and y axis back in here like so. So we are in the fourth quadrant. Now, remember that points x, y are cosine and sine. So the x value is cosine, the y value is sine. So right now we want to know about the y value since that's sine. This will be negative because in the fourth quadrant the y value, it's down, all right, it's below the x-axis, so it's going to be negative. Okay, so it's definitely going to be negative sine of pi over 3. So let's continue. We have memorized the sine of pi over 6 and the cosine of pi over 6. And then we know that the sine of pi over 3 and the cosine of pi over 3 will just be the opposites of those. And we always will write that down. So anyway, sine of pi over 3 is radical 3 over 2. So we'll have negative radical 3 over 2. Alright, but this is not the answer because we really want the cosecant of 5 pi. Okay, I'm so having so much trouble. The cosecant of 5 pi over 3 will be the reciprocal of this. So that's going to be negative 2 over radical 3. So that is the answer. Alright, let's go ahead and stop this video there. We have several more examples to come, but I will put additional examples in the next video if you want to see them.